In this video, we will consider the case in which all the outcomes in the sample space have the same probability. Let's start with this example. Let's suppose that we roll a pair of dice. In this case, to do the sample space, we can do a tree. For the first die, we have 1, 2, 3, 4, 5, 6, and for the second die we have again 6 and 6. Then the sample space will look like 1, 1, then if we consider the event E, the sum is 7. Then this event has the following outcomes. It has the outcome 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, and 6, 1. Therefore, since this sample space has 36 elements, then the probability of each outcome is 1 over 36, and for that reason the probability of this outcome is going to be 1, 2, 3, 4, 5, 6, 6 over 36, and this will be 1, 6. Let's suppose that we consider the probability of having the sum equal to, let's say, 9. Let's see what is this event. We have 6 and 3. We have 5 and 4. We have 4 and 5. And we have 3 and 6. In this case, this event has 1, 2, 3, 4. And then the probability of F would be 4 times 1 over 36, which is 1/9. Let's consider the following example. Let's suppose that we have a container, and this container has 11 balls. We have 6 white and 5 black. And the experiment consists in taking 3 balls from there and then computing the probability of getting 1 white ball and 2 black. Then in this case, the experiment is taking 3 balls, and then the event that we want to compute the probability is getting 1 white and 2 black. We're going to do this problem in 2 different ways. The first way is we're going to assume that the order matters. Then in this case, the sample space would be like, it will be like ordered pairs, like, let's say white 1, white 2, white 3, white 1, white 2, white 4, and it will have some amount. Let's compute that amount. In order to compute the number of outputs of this sample space, we use the basic counting principle. And we notice that first we select 1 ball. That means that in this case N1 is 11. Then we select the other ball. That means that N2 is 10. And N3 would be just 9. Then the number of elements of the sample space, if we are taking into consideration the order of the balls, then it's going to be 11 times 10 times 9. Now we need to find out how many outputs do we have in this event. This event is getting one white and two blacks. Then we can separate that event into the union of three events: E1, union E2, union E3. This one is where the white ball comes first. This is white ball first. This is white ball second, and this is white ball comes third. Then the number of elements of E1, again using the basic counting principle. Then how many ways can we select a white ball? It will be 6, and then times how many balls can we select a black ball? 5, and then a second black ball would be 4. For E2, it will be how many ways can we select a black ball? It will be 5 times how many ways can we select a white ball is 6, and how many ways can we select a second black ball? It will be 4, and same things here. It will be plus, and here it will be 6 times 5 times 5. This is 120 plus 120 plus 120. That means that the number of elements in E is 360, and then the probability of E, since we are assuming that all the outputs are equally likely, is going to be 360 over 11 times 10 times 9, and we can cancel this, and then we get that is 4 over 11. Let's try to do the same problem, but now let's assume that we are not considering the order in which the balls are taken from the container. Then in this case the sample space is going to be just like this. It will have like white 1, white 2, and white 3, but notice that now this is a set and not a triplet, and it will have more elements. Then in this case, let's start over. Let's just keep the answer from before. Then in this case, the number of elements of omega would be how many ways can we take 3 balls out of 11, and the order doesn't matter. Then this is essentially 11 choose 3, which is 11 3. Right? That's the number of elements of omega. We're assuming that all of them are equally likely. Now let's consider this event, getting 1 white and 2 black. Then we can use the basic counting principle. And then in how many ways can we select a white ball? Then in this case there are 6 ways that we can do that. And now in how many ways can we select 2 black? We have 5. Then the answer will be 5 choose 2. Right? It will be 6 times 5 factorial over 3 factorial times 2 factorial. This is 6. Then it will be 120 over 2, which is 60. And what is 11 3? 11 3 is 11 factorial over 3 factorial times 8 factorial. And this is 9 times 10 times 11 over 6. I can cancel a 3 and then a 2 here, and it will be 5. Then is 15 times 11, which is 165. Then in this case the probability of E would be 60 divided by 165, and we can check that we get again 4/11. Then in this case, it doesn't matter if we consider the experiment just by taking one at a time and considering the order in which the balls were taken, or just selecting the three at a time. Okay, let's explain the probability of a flush. First, let me show you the cards in a poker game. We have 4 kinds. We have 13 clubs, 13 hearts, 13 spades, and 13 diamonds. And we say that we have a flush if we have 5 of a kind, like 5 of these, 5 clubs, or 5 hearts, or 5 spades, or 5 diamonds. For example, if we have the 1 of hearts, the 3, the 7, the 9, and the 10, and all of these are hearts, then we say that we have a flush. Let's find the probability of getting a heart. Remember that when we start playing, we receive 5 cards. Then our sample space is going to be the collection of 5 cards. Then in this case we can have like 1 of hearts, 3 of hearts, 2 of spades, 5 of spades, and 1 of diamonds. This will be just one hand, and we have a lot more. How many? In this case we have 52 cards all together, and we are selecting 5. The order doesn't matter. That means that the number of elements in omega is what we call 52 choose 5, and we denote it by 52 5, which is 52 factorial over 5 factorial times 47 factorial. Now the event E is we get a flush. Then we need to count how many elements we have here. Notice that this is just one example, but we have certain amount. To count the number of elements on E, we can use the basic counting principle. And then we can do the first stage would be to select what type of card we have. Then we have like N1 equal 4. And the second stage would be to select the 5 cards in that type of card. Then N2 would be 13 choose 5, which is 13 factorial over 5 factorial times 8 factorial. Then the probability of E, remember that we are assuming that every hand has equal probability, they are equally likely outcomes. Then the probability of E would be the number of elements of E over the number of elements in omega, and in this case the number of elements in E is 13 factorial over 5 factorial times 8 factorial, and the number of elements in omega is divided by 52 factorial over 5 factorial times 47 factorial, and this is equal to 33 over 16,660, which is equal to 0.002, approximately equal to 0.002.